The next presentation will be delivered by Przemek. He's a funny guy, so I guess the real topic is funny tales in the land of data. Welcome, Przemek.
All right. Szymon told me that he has planned this in advance because you will be drunk and my presentation will be skipped anyway. So, okay. So what I'm going to tell you today is a fairy tale, but actually this fairy tale has basis in some real experience with analyzing data, with business intelligence, with what I'm doing professionally. And this is actually going to be some kind of a quiz. And I have nice t-shirts. Surprise, this is different design than it's needed until you ship it. It's something like that. And there's extraordinary talent on the back, so it's really nice thing to wear. Yeah, of course. And the only problem is that while I have different colors, I have only one size, M. So, but you can always give it to girlfriend or sister or boyfriend, whatever. All right, so I promised fairy tale, so I will tell you a fairy tale. Let's assume that there was a very nice country and dwarfs were living there, and dwarfs have found a mountain full of gold. So they started mining gold there. What happened next is that that's very nice gold piece. What happened next is that more dwarfs were attracted to this mine, and they collected more gold, and everyone was happy or supposed to be happy. However, not everything is so great, like in fairy tales, like there's a dragon or whatever. What happened here particularly is that after 12 months of operation of the mine and more dwarfs coming, they decided to change the provider of hammers. And they use hammers for crushing rocks and getting the gold from it. So it's very important equipment they use in this mine. So they changed the provider of the hammers. Couple of more months passed, and one dwarf, the oldest one, is coming to the boss and saying, "Hey man, the hammers are no good." All right, so the first question, as a data-oriented person, what would you do?
Ask the question why.
Yes. Okay, so do you want M size?
No. Of course I do.
All right, blue one? Okay, why? So let's look at some data. We want to try to get reality and see if what this guy is saying has any relation to reality. So as a typical mine, we can get this summary of data where we have a couple of columns. In the first column, we have the month of mine operation. In the second column, we have number of dwarfs on each particular month. So as we can see, the number is growing. In the third column, we have total production of the mine in ounces of gold. And in the last one, we have a summary of production per dwarf. So we take the production and divide this by number of dwarfs. So we have an average production by dwarfs. Of course, we want to present this data to dwarfs, and dwarfs don't like reading tables. They want to look at some charts. So let's build some charts. So I have R instance ready here. Who knows R? Okay, who likes R? I know, I'm right. I don't like R. I'm using it sometimes, but I don't like the syntax and the fact that it's a bit chaotic sometimes. However, it's a very powerful tool, and it's amazing what you can do with just a few lines of code. But sometimes, until you get which lines of code you have to write, it's another story. Yeah. So I have already loaded this CSV file, all.csv. So let's plot it. I can use a qplot, for example, and take month sequence.
Can you use bigger font?
Excuse me?
Can you use bigger font?
Oh man,
No.
I don't know. Who knows how to? I never did that. So.
Don't bother. Command It's possible.
Is that good for you? Okay. And let's add a model, smoothing. All right, so let's see the first chart. We look at the number of dwarfs per month, so nothing bad is happening here. We have more and more dwarfs that are working in our mine. All right, let's see what was the production, if production is really growing. Wow, it's increasing like tremendously, exponential growth, so looks good. So let's take the average production per dwarf and see if the average production per dwarf is changing. Maybe it's indeed lowering in time. So we can use qplot again. We have this pre-calculate already. And okay, it's lowering, but then it's increasing. And the new provider of hammers started providing hammers to dwarfs that started working with us on the 12th month or the 13th month of the operation of company, so somewhere around here. So actually it's increasing. So is there any problem? Yes or no? Who says no? Let's make a vote. Who says there's no problem? Excuse me? Well, let's say that it's indefinite. So when a dwarf starts using a hammer, it uses it like all the time. The mine is not that old. It's like operating for 18 months in total. So
we assume that at that point we switch to trials, we've thrown out all the old hammers and we got new ones.
The dwarfs that were hired by the mine since the 13th month got the new hammers and the. Okay. Yes. Okay. So let's vote. Who thinks there's no problem and who thinks there? Okay. So and there's problem. So let's start with the people that think there's no problem and the new hammers are all right.
No problem with the hammers.
Yeah. All right. Who thinks there is a problem with the hammers? Everyone else? Okay. And the other group is not decided. Okay. But I think that this was a good question. So just tell me which color, blue or gray? Blue. All right. I think I will try. Whoa. No. Sorry. Almost, just 10 meters. All right, so what we can do actually, I think that like what the question you raised goes into the right direction, because I believe that when you look at the hammer, it looks quite fatigued, like it's by being used by crushing rocks, it probably deteriorates and is less effective. Like maybe it's smaller, becomes smaller, whatever. So let's try to model how the hammer effectiveness deteriorates over time. So what we can do here is we can pull another table from dwarfs gold mine SQL database, whatever, and take the production of each dwarf relative to the month someone applied. So if I applied on, let's say, the 3rd month of the operation of the company, I calculate only relative months. So what was my production in the 1st month as a worker in the company, in the 2nd month, in the 3rd month, and etc. And let's split this data into two groups. The first population are the dwarfs that are using the old hammer design. The second population are the dwarfs that are using the new hammer design. Do you understand what I'm saying, or it's okay? Okay, perfect. And let's see if the effectiveness of hammer deteriorates over time, and if there's any kind of difference. All right. So thankfully, I made the SQL query to these dwarfs SQL databases. All right, and I have CSV files handy. So we have the new hammers. Okay, some results, and we have the old hammers. Okay, let's just take a look at the data. Like, let's plot one of these tables. We have relative month and production. So let's see what was the production for each relative month. It doesn't look very good. Why it doesn't look very good? Because we have data grouped by month. So all the results are put into a single month and all this are overlaid together. But thankfully there's a simple technique we can use to make this look more decent. We can add a jitter, which will basically like randomize one of the axes, and it will be easier to see the data. So let's add some jitter, and let's move to ggplot, by the way, which is like a more sophisticated version of qplot. Or qplot is a simplified version of ggplot, which I honestly recommend when dealing with R. Okay, so we have this, we add aesthetics, relative month, y-axis is production, and I define that the way we plot points, we're using shape number 19, which is like a filled circle. It's very, very easy, right?
Yeah.
Actually, this is one of the easiest part of R, in my opinion. So we add some jitter. These are just some values. I know that will look kind of okay. Don't add jitter on the y-axis. And to make it look nicer, we'll add some transparency. Oh, okay. Looks better? No? Okay, yeah, but we see there is some trend. That's
The x-axis, the time that work has worked, or the time when he started working?
okay. So when we see point here, for example, it means that 4 months or 4 and something months after some dwarf started working, he made a production of I don't know, 10.2 or something.
Is this total production?
No, this is production for a given month. All right, so let's try to overlay the new the production made by dwarfs that were using new hammers with the production of the dwarfs that were using the old hammers. So what I'm doing is that I'm going to add a category for all of this for this data frames. No, Alt. Let's bind them together. And again, let's make a ggplot. Alt and new. Let's add to the aesthetics color, which is defined by type. Yeah, and the rest might be the same. Let's see what we got now. Okay. So the red ones are the new hammers, and the blue ones are the old hammers. Are this population different? What can we do now? Ideas? Perfect. Which shirt do you want? I think I have only gray and dark gray. The gray is a polo one.
So dark gray.
Dark gray. Okay, so regular T-shirt, right? Okay, thank you. So what we're going to do now is we're going to add trend line, or basically we're going to make a regression, and on this points, and let's see what the regression tells us. It's really trivial to add regression when you are using ggplot to the chart.
Why do we assume that we should fit a linear function?
Excuse me?
Why do we assume that we should fit a linear function to that?
Linear fit?
Yes.
Well, that's just good first guess.
Okay. And how are we going to determine whether these two linear fits are actually different?
Excuse me.
How are we going to determine whether these two linear functions we get
Is it good or bad?
actually different?
We can compare them visually. First, we have confidence intervals for each of them, or confidence bounds, so we can say that with 95% probability one fit goes here and one here go here, and confidence interval and probability. But yeah, okay. But I'm not that good in statistics. This is actually not a trivial question, and the right solution is using ANOVA or other methods for statistical analysis. So that's broad topic, and I just want to make it like more or less simple, easy. Is it easy? Okay. Okay, anyway, let's add this regression line and see what we got. Oh, no, so it's different. Now we can clearly see it's different. Maybe it's not so clear on the like rows in the back, but but yeah, the regression shows like total different characteristics here, and furthermore, we have this these bands here. It's not very clear, but like everything that falls within here is within 25% confidence interval. So that's quite significant difference, like from statistical perspective, between these two trend lines. Of course, if you want to dig deeper, then there's really nice. There are many ways to analyze this further on. Like, and with R, it's really simple to use ANOVA, but you have to have some good statistic background. But I think that we can just leave it here and see that, well, this old dwarf was right, and indeed there was a difference between this this new and old hammers, even if most of us voted for no. Okay, we can just do one more thing more. It's very simple. Like, we can try to assess how much gold more we could have mined if the new dwarfs would use the old type of hammer only, and actually it's very simple to do. We just, because we have the data here, we have the months that each of the dwarfs from using new hammers have worked on. So this is like the argument for the model we had in regression. Okay, so let's create the model once again. Production depending on relative month using the old hammers. So we can check the coefficients. It's simple linear. Okay, that's what we have, and we can now use predict function, and let's put new column possible production into this data frame, where we use this model we have just came with on the dwarfs using new hammers, and now simply we can sum what was the possible production. What was the actual production? And splitting this one by another will reveal that this is just, I think, 0.5% more. Yeah, more or less. Okay, that's it basically. So, do you have any questions or comments? Yeah.
So if I'm getting this right, the new hammers are still make production better, but they will deteriorate faster?
No, the new hammers are deteriorating quicker, and they are not better. Actually, that's the reason why the chart, this chart shows this like rise, is that because we had exponential growth of dwarfs. So at some point the growth was so high that it elevated the curve up, even if the hammers they were using were worse.
But on the graph it's very dwarf, so it doesn't.
Because hammers deteriorate over time. So if you put a large influx of dwarf, we have new hammers, independent of whether you have the old one.
Yeah, exactly. Because new hammer after let's say a month is still better than old hammer after 4 months, for example.
So what we want to do is just issue the old hammers once again.
Yeah, well, depending how much they cost, maybe like basing on the difference, it doesn't make sense to use old hammers if they're expensive. Just use new hammers and change them more frequently. Like, there are many answers to this problem. This is like a.
It doesn't have to be wrong.
Well, it doesn't have to be wrong. However,
from our perspective, this is wrong.
yeah, but yeah, what I'm trying to raise here is that when you're making decisions based on data, it's sometimes it's easy to get trapped into some metrics that might make sense, but in fact, what's driving them underneath is a process that sometimes you have to understand to make right decisions. And it's really worth to dig deeper and try to understand, try to model processes if you have the means to do so. But we had the means because we have the data here, and make truly decisions based on data. All right, thank you.